Hello, today we're going to learn how to solve energy problems in physics. And today we're focusing on kinetic energy, potential energy, and the conservation of energy. Before we solve the problems, we're going to look at the formulas that we need to know to solve the problems. So first is the kinetic energy formula. Ke is equal to 1 over 2 mv squared. While Ke is kinetic energy, m is mass of the object, v stands for the velocity of the object. Next is the potential energy formula. Pe is equal to mgh. M is mass, g is the acceleration due to gravity, which is 9.8, and h is the height. Next, we have the work energy theorem. W stands for the work done in joules, which is J. Work is equal to change in energy. Conservation of energy. E initial is going to be equal to E final. So our first problem is an 1 kilogram rock is dropped from a cliff which is 90 meters high. After falling 20 meters, what is the kinetic energy of the rock? So we're going to summarize what is the problem about. We have mass of the subject, which is 1 kilogram. The total cliff height is 90 meters, and the rock falls 20 meters, so it's going to be h falls equal to 20 meters. To be able to find the kinetic energy, first we need to find the potential energy that is lost. Pe lost is equal to mgh fall. This is the formula that we mentioned earlier. Here is 1.0 kilogram multiply with g. G is the gravity, which is 9.8, and multiply with the height, which is 20 meters. Using the calculator, we could have 196 joules. Next, we're going to use energy conservation. Since Ke at the top will be equal to 0, and we have the Pe formula, after falling 20 meters, Ke will be equal to Pe lost, which is calculated earlier, is 196 joules. This happens because the loss in the potential energy will become kinetic energy. So our final result is 196 joules. Next, we have a little bit longer problem. A 55 kilogram diver falls freely from a diving platform that is 3 meters above the surface of the water in the pool. When she is 1 meter above the water, what are her gravitational potential energy and kinetic energy with respect to the water surface? So what we're finding is the potential energy and the kinetic energy. We're going to summarize what the question has given. We have the mass, m is equal to 55 kilograms. H at the top is equal to 3 meter. H will be 1 meter above water. Okay, so first we're going to find the potential energy at 1 meter above the water. So Pe will be equal to mgh, and will be mass is 55 kilograms multiplied with gravity 9.8 with the height, since it's 1 meter above the water, is going to be 1, and it will be 539 joules. Next, we're going to find the total initial potential energy. Pe initial will be equal to mgh, but this h is like the platform height, so it's going to be h top. So mass is 55 multiply with gravity 9.8 with the height of the platform 3. which give us the result of 1617 joules. To find the kinetic energy, we're going to use the conservation of energy. Ke will be equals to Pe initial minus the Pe that we found earlier, which is the Pe at 1 meter above the water, which is 1617 minus 539 will give a result of 1078 joules. So we just solved two problems about kinetic energy, potential energy, and the conservation of energy using all the formulas that we just listed above, which are the key formulas for this concept of physics. Thank you.